In this section, we go into more advanced concepts and techniques. Some of the things we cover in this section include how to compare differences in Git, how to branch, merge, and resolve conflicts, how to mark important milestones in Git with tagging, how to save work in progress, and even how to time travel. This section is likely to grow as additional advanced topics are added later. By the end of this section, you'll have a solid foundation and several intermediate to advanced concepts mastered, at least locally. Branching and merging are important concepts in Git. Git makes doing both branching and merging a lot easier than previous tools, and thus many workflows rely upon them. As discussed before, a branch is just a timeline of commits. More accurately, branches are the names or labels we give timelines in Git. We can create and delete branches without affecting timelines. All we are doing is creating or deleting labels of commit ranges in Git. So far, we have been working on the default master branch. Now, we can create a new branch to do a bit of work and then rejoin the master branch by merging in any changes that occurred on the new branch. While merging, Git tries its best to automatically merge when possible, which leads to several types of merge scenarios possible. First, the fast-forward merge. This happens in the simplest of cases when no additional work has been detected on the parent branch, or in our case, master. Git will simply apply all commits from the other branch directly onto the parent branch, as if we never branched off to begin with. Of course, we can disable the fast-forward merges if they are undesired for some reason. Secondly, automatic merges. This happens when Git detects non-conflicting changes in the parent branch. Git is able to automatically resolve any conflicts. In doing so, the old branch's timeline is preserved and a new merge commit is created to show the merging of the two branches. Thirdly, manual merge. This happens when Git is unable to automatically resolve any conflicts. Git enters a special conflicting merge state, which means that all merge conflicts must be resolved prior to moving forward with a commit. Once all conflicts have been resolved, those changes are saved as a merge commit. In addition to branches, tags, and other labels for commits, Git has special markers or pointers. One popular marker is called head. Head is normally the last commit of the current branch. That means that as we switch branches, the location of head moves to match the last commit location of that branch. While this is generally true, it is also possible to manually move the head location someplace other than the last commit. We'll cover that in the advanced section of this course. For now, head points to the last commit of the current branch. Welcome. In this video, we're going to create and manage branches other than master in our Git repository. I'm currently in the demo Git repository. And from a previous video, we have a modified readme.md file. And that's okay. Maybe we intended that this file should be modified experimentally or as part of a feature of a next update. Either way, we can use feature or topic branches in order to separate out changes that we want to make off of master. If we use the git branch command, we can see that we have a single branch named master. And right now is highlighted green and with an asterisk, which denotes that that's the current branch. Now I could create another branch by using the branch command and then separately switching to that branch. But I can accomplish both by using the checkout command with a -b option. Type git checkout -b for creating the branch, space, and then the name of the branch you wish to create and switch to. I'm calling it updates. And press enter. Now a couple things have happened. One, it created a new branch called updates. Then it switched to that new branch. And since there were modifications pending in the working directory, it carried those modifications forward into that new branch. This is a technique that you can use when you start working on master and you decide later that before committing that these changes really should be isolated into their own feature or topic branch. All right, let's continue. We see that we have just some updates, and I'm going to add on a branch. Save and close, back at the terminal. We're going to add those changes, and now let's commit. Adding updates from branch. Great. So to get status, it shows that I'm on branch updates, and I'm in a clean working directory with nothing to commit. If I do a git hist, something that should be noted, we have the latest commit, which is on head and updates. But if we go one back, we see that is the commit that master is associated with. We can see what the changes are by using our diff command. And the diff command will allow us to pass in the names of branches instead of commit IDs. So I'm using git diff updates space master. And it shows us what's different. All right, let's say that I'm finished with whatever updates I needed on the updates branch. In order to integrate any changes on my branch, I need to first switch to my parent branch, which is master. In order to switch branches, we use the checkout command. Git checkout branch name, in this case, master, and press enter. Great. Now let's look at our history from the master perspective. Again, it shows that head is now on master, since head typically means the last commit on the current branch. And since the current branch is master, head and master are sharing the same commit ID. Since our hist command specifies the -- all parameter to our log command, we also notice the commit ID associated with the updates branch. Let's go ahead and merge in those changes. Type git merge space and then the name of the branch you wish to merge into the current branch. Then press enter. For this merge, it's such a simple merge that it's able to do something called a fast forward, which means that we're going to pretend that you never really switched away from master in order to make those updates. So we're going to apply those commits directly to the master branch. Now if we do a git hist, we see that head, updates, and master all point to the same commit ID. That's the effect of a fast forward merge. There are options to disable fast forward merges from happening even though they may be possible, but most of the time, you'll want this behavior. Once we have completed merging in our changes, we no longer need the updates branch. Effectively, branches in Git are just labels of timelines, and once they've been integrated into the main timeline, there's no need for them anymore. Let's use the git branch command, git branch -d for delete, followed by the name of the branch we wish to delete. In this case, updates. Press enter. Great, we've deleted that branch. We're back to just the master branch. We do a git hist, we see we no longer have the updates branch associated with that commit ID. Note, the history didn't go away, just the label updates did. Welcome. In this video, we're going to walk through the steps necessary to cause a conflict and then resolve that conflict when working with branches. In my terminal, I'm currently in the demo Git repository. I'm on the master branch with nothing to commit since I'm in a clean working directory. While on the master branch, let's take a look at our README file. Alright, so we have our updates that were integrated from our previous example. We can close out of here. Let's create our branch that we're going to work on. I'm going to create a branch called Very Bad. I'll switch to it, git branch -a, which shows us all branches. We see that we have our master branch and our Very Bad branch. And at this point, our Very Bad branch has the green highlighting and the asterisk, denoting this is the current branch. Let's modify our README file. Let's do it in such a way that will cause a conflict, which means updating the same part of the file on both branches. So I changed that line to, this is bound to cause trouble. Let's go ahead and save and close. I'm going to use my express commit technique, saying it's a very bad update. And we have very bad update at the very top, which is the last commit. Let's return back to master. And before I merge in those changes, I'm going to pretend to be another developer, or perhaps I'll just forget about those changes that I made on the Very Bad branch. I'll modify our README file exactly in the same location. change that to, I hope this isn't much of a problem. Save and close. Back at the terminal, again, another express commit, causing issues again. Now, let's merge our very bad branch into our master branch. Let's remind ourselves of our branch names. Git merge very bad. And as expected, the auto merging was unable to resolve the conflict. Auto merging's pretty good, but it's not perfect and it can't read mines, so it doesn't know which version of our file we want. This places us in a merging state, which is denoted by our command prompt with the branch name on one side and /merging. The README file is the file that's implicated in the merge conflict. If we cat the file, which just outputs the entire contents of that file, the current version has these weird carets that denote the parts of the file that are conflicted. And you can see that head versus very bad. Since this happens to be a very simple case, we could manually modify this file. We have a merge tool configured with Git, so let's use it. While in a merging state, just type git merge tool, then press enter. And P4Merge launches with a three-way merge in progress. And we can see that we have the various versions of our file and the possible solution at the bottom. Any number of these possible solutions to incorporate. Let's say I like that one. Once I'm done, I need to click the Save button in order to save those changes I've made to the README file. Now, once I've done that, and I have no further conflicts to resolve, I can quit P4Merge. Command Q. If there are no more files with merge conflicts, then you'll simply return back to the command prompt. To complete the merge, we need to commit what we've saved. Git commit -m, we can pass in our commit message, resolving conflict, then press enter. If that successfully resolves the conflict, you'll be returned back to a command prompt that looks more normal. In this case, we're back to our branch name simply in parentheses. If we do git status, we can see we have a .org file that is untracked. .org is the original version of the README file. Well, I don't like .org files laying around in my Git repository that I might accidentally add back to my repository. Let's add this back to our git ignore. Let's do our express commit, updating ignore to exclude merged files. Great. So we still have that .org file. I really don't like that guy hanging around, so I'm just going to delete him. Great. Welcome. In this video, we're going to look at Git tags. I'm currently in the demo Git repository, and we're on the master branch with nothing to commit. If I do a git hist, you can see that we have several commits that are part of this repository. And at this point, we've been working with the repository for a pretty good long time. So I'd like to mark this point in the repository with some type of milestone. To do that, Git supports a notion of tags. The tags are just labels that you can put at any arbitrary commit point. And by default, if you don't specify commit, it'll be the current commit or head. And there are two types of tags. Lightweight tags, which you can just give a name and Git creates it for you. If we do a git tag -- list, you can see that my tag is listed. Also, when we do our git hist command, we see tag : and then my tag. Now, this is a lightweight tag. There's no associated information with it. What I prefer using are what's called annotated tags, which means they have extra information associated with the tag. So before we do that, let's delete my tag. Type git tag -d for delete, then the tag name. Great, we've deleted that tag. If we use the syntax git tag -a for annotated tag, then the tag name v.1.0, then -m, followed by, in double quotes, a commit message. Effectively, we're associating a commit message with this tag. Double check and then press enter. Usually no news is good news. Git tag -- list. We have our v1.0 tag. And we see that we have our tag : v.1.0, mentioned in our commit history. But so far, we haven't seen anything different than our lightweight tag. So where does the annotation come in? Well, if we use our git show command and then specify our tag name, git show space v.1.0, then press enter. It shows us that we have our tag v.1.0, the tagger, which is myself, the date that it was tagged, the quote-unquote commit message that goes with that tag, followed by the rest of the information for that commit that's associated with that tag, including its own commit message from before. This is really useful when you're trying to note major milestones, and you might want to associate some information with it. Welcome. In this video, we're going to take a quick look at stashing. I'm currently in the demo Git repository on the master branch in a clean working directory. Let's modify the README file. And doing git status, we see we have our modified file. But what if we decide that we're really not supposed to be doing that right now? What if we decide that we really should have started this on a branch, or maybe we need to change context and work on something else for a while? Well, we can do that by using Git's stashing ability. All right, so let's do that. Do a git stash, and it tells me that the head was saved, which is the last commit on the current branch, which is master. And it saved it in a work in progress. If we do git stash list, it shows us our stashes. We have a work in progress on master, and it shows us the last commit and the associated commit message. After the stash, we're actually back on a clean working directory. Let's apply our emergency fix, if you will. Save and close. Updating the license file. This will qualify as our interruption that we had to take care of. Back to a clean working directory. Now let's apply our stash. Do git stash pop. So that will do two actions in once. One is an apply, and then the next is a drop. The stash apply will apply whatever the stash is, the last stash. In this case, we put those changes back in the README file. Then after that, it dropped that stash that was applied. Now if I do a git stash list, I have no results. If I go back to the README file, you can see the README file was updated like it was prior to the stash. Let's move forward by committing our update, updating README again. Back to a clean working directory, and we're done. Welcome. In this video, we're going to do a little bit of time travel with reset and reflog. I'm currently in the demo Git repository, and I'm currently on master with nothing to commit since I have a clean working directory. Let's take care of that. In another line, I'm going to put updates in stage. So I did the git add to add that README file change to stage. And then I put another line to denote some changes that we have in our working directory. To do a git status, we see that we have our modifications detected in both the staging area and just in our working directory. Now, there may be times when you need to go to a different commit point. If you made a mistake in the last commit, for example, that you didn't need to have committed, you want to roll back to a previous commit. That's certainly fine. Do a git hist. You can see we have several commits to choose from. So I'm going to do a git reset. I'm passing in the commit ID that I want to reset to and the option --soft. And the reason I'm doing that, there are actually three distinct ways of resetting. There's a soft reset, which is what I'm about to do. There's the default, which is called mixed. And then there is hard. The soft reset is the least destructive of them all. Basically, all it does is change where head is pointing. So let's try that out. Usually no news is good news. Make a note of where head is pointing to right now, which is 67B1242. If we do git hist, as expected, head is now pointing to CE2C810, which is the commit ID that we passed in to the reset command. Let's check out our git status. we have files that have been modified and in our staging area. That's what Soft allows us to do, is simply change the commit ID that head is pointing to, which means it preserves the Git staging area and our working directory. Effectively, we can back out our changes, make minor modifications to them, and then commit where head is currently pointing. Let's try this another time. I'm going to choose the commit ID 6AD74DF. And although mixed should be default, there's no harm in specifying it, just to make sure for our example. Let's go ahead and press enter. Now what's interesting, it actually unstaged a number of changes. If we do a git hist, we can see that head is now pointing to 6AD74DF. If we do a git status, we have several files that have been unstaged and placed into our working directory. There's nothing in our staging area. Let's try this one last time. Now type git reset followed by the commit ID. I'm using D444E90 space -- hard. This is the most destructive of all the reset modes. Now press enter. It simply tells us that our head is now at a new location. If we do a git status, we see that our working directory is now clean, which means any changes that were pending have been wiped out, along with anything that was in the staging area. Again, a hard reset is the most destructive type of a reset. Apart from the handful of changes we've made at the very beginning, we really haven't lost a whole lot. And you're thinking, well, if we do a git hist, our head is now pointing all the way down to the second commit in our history. If we just do git log -- line, that is, we leave out the -- all, we see we only have 2 commits being listed. So if you see this list of history, then you might be a little worried. And that's okay, because there's another command that we can use in conjunction with reset that makes things a lot better. It's called reflog. Although both gitlog and getreflog share similar sounding names, gitlog shows us our commit IDs and getreflog shows us all the different actions we've taken while in this repository. This allows us to get all the way back to a specific commit ID if we need to. For example, let's go to head at 3, which is the last commit before we did any resets. That's 67B1242. We're going to copy that commit ID, do git reset. At this point, since there's no pending work, we can leave it at the default, or we can specify hard. Then paste in our commit ID, and then press enter. We've now moved our commit ID back. Do git log -- one line. Looks like we have our history back again. And using our git hist alias, we can see our git history looks like the repo prior to doing any of the resets. Using reset plus reflog really does provide you full control over time travel within your Git repository.